present our second presentation.
For lessons 4 through 6, and I'm Kurtis Kubal.
Alright, a selection control statement that allows choosing between two or more paths of execution in a program. The paths that are executed are determined by certain conditions that are set. These conditions are ran and can either be a Boolean true or false. If a condition evaluates to be true, the code path will be executed. There are one-way, two-way, and multiple-way selectors that exist in Java.
The if statement without an else is a one-way selector. The if statement tells the program to execute a certain body of code only if a particular test to true. If the condition evaluates to true, then the body of the code contained in the statement will be executed. If the condition evaluates to false, the body of code will be skipped altogether. An example of a good time to use the single if statement is when you already know it's okay to set a variable as false, but sometimes you may need to change that variable to true or another similar situation. It is also a good time to use an if statement if there is a particular case that something else should happen, but other cases don't necessarily need any extra code to be executed.
In the example, the green box shows that most of the time the value of gift will be false. In the yellow box, however, we want the value of gift to sometimes be true. We can be very specific with our conditions to make sure that the code is executed for very specific circumstances that we are anticipating will happen.
An if-else statement is of a two-way selector. An if-else statement provides a second path of code to execute if the condition in the if statement evaluates false. So an if-else statement is best used when we want a certain body of code to be executed, no matter what, true or false.
The if there can be multiple paths in which the code is executed. The if statement is also described as a ladder because the if-else or else-ifs can multiply into many steps until a false. This statement is useful when there are many different things to check to determine the right set of code to run. The final else can be understood to mean all other conditions that are not listed. Perhaps we can use a store's checkout to explain the ladder to our if-else-if. The store wants to give a percentage discount to the customer depending on how much they spend. Our customer will spend $42. The first if checks to see if the total spent is less than $10. The condition is false, so we continue on to our second step on the ladder, which is the else if, which asks if the total is less than $25. False again. This time it is true, and the discount will be added to the total. So now we one step at a time until we arrive at the one fit for the situation.
The switch statement is also a multiple selector. The switch statement can have a number of possible execution paths. A switch works with primitive data types instead of Boolean expression, which sets them apart from if-else, and if-else-if statements. The switch is best used when you are dealing with many set responses. There is, however, a default condition set that acts like else at the end of an if statement. It is optional. The breaks between the cases are also optional, but if a break is absent, the program will run to the next case and execute that code as well. The best feature of this switch statement is the formatting that makes it easy to read.
This is an example of a switch implemented in our game menu view class. Many of our view classes have a switch. To make this menu work, first another function has to receive user input and call the doAction function, passing the user input as a character. The switch statement looks at this passed character and makes a decision on what group of code to run based on which case the character matches. If the character matches none of the class cases, the default case, not shown here, will prompt the user for a listed option in the menu.
A repetition statement alters the flow of control in a program. Repetition statements cause blocks of statements to be executed over and over until a condition is or is not met. There are three kinds of repetition statements in Java: the for loop, the while loop, and the do-while loop.
The for loop will cause a block of code to be run a fixed number of times. When declaring a for statement, we have to follow the syntax and declare an initialization, condition, and increment. The initialization is usually used to set a loop index. To set a loop index a start value, the index is basically a counter to keep track of how many times we want to iterate through the loop. The condition is a Boolean expression that evaluates to either true or false, similarly to an if statement. The condition is checked each time before the code in the for loop's body is executed. If the condition evaluates to true, the code will be repeated. If it evaluates to false, the loop body will not be repeated. The increment changes the index, either through addition or subtraction. This is done at the end of the loop body. The condition that usually causes the loop to stop repeating is that the index has been changed by the increment that will cause the condition to be false.
A while loop first checks the condition, and then when it runs as true, the code contained in the statement is then run. This means that if the condition is false on the first time through, it will never run. The while loop has the potential to become a loop if the condition is not changed elsewhere in the block. The best time to use a while loop is when we do not necessarily know how many times we want the code to be repeated.
A do-while loop first runs the code contained in the statement and then checks the condition to determine if the code will be executed again. A do-while loop is best used when you need the code to run at least once. A great example of when to use a do-while loop is a menu. You always want a menu to display at least once, then display again if a correct option is not chosen.
This is an example of a do-while loop in our program. When the display function is called, it will go ahead and run all the statements in its body. The last statement will use the user input in the switch shown earlier to make a choice on what happens next. With the condition at the bottom, the menu will continue to be displayed and user input will equipment.
An array is a container object that holds a fixed number of values of a single type. The length of an array is established and fixed at its creation. Each time in an array is called an element, and each element can be accessed in an array using its numerical index. Numerical indexes for arrays start at 0 and count up.
The following is a function from our game control class. The function is used to go through the array of inventory items and find the item with the greatest quantity. The first thing that happens is that a copy of an array that exists is created using a getter. An inventory item called max is assigned to the first place in the inventory item array. The item max is an object placeholder, which is used to create a copy of the item with the greatest quantity. The counter is then created. We then go into the for each. The for each loop is a modified loop used just for this purpose, going through all the objects in an array. In the loop body, an if statement checks whether the current inventory item being looped through has a greater quantity than the max object, which has a quantity of 0. If it does, the max object is set to that inventory item. If the item being checked has the same quantity as max, the counter will be added to. This will continue until all the items are checked. At the end, if we At the end, we check if the max object has a quantity of 0. If it does, there are no items in the inventory. If the counter is greater than or equal to 1, this means that there are an equal amount of one or more items. The counter is equal to 21, which is the sum of all the items in the array. This means that there is an equal amount of all of the inventory items. We can similarly iterate through an array using a standard for loop. We would set the initializer to 0, a condition that as long as the initializer is less than the length of the array, it will loop, and the increment of 1 will go through each item in the array.
We can use inheritance when creating new classes that will do the same things as other classes, such as menu view classes that all use a similar method of displaying menu options and receiving input. Inherited functions and subclasses can be used directly, and new functions and attributes can be created in subclasses that do not incorporate the functions found in the interface. These functions are to all be used similarly.
The left screenshot demonstrates how the superclass implements the interface. We simply use the implements keyword followed by the interface name. This ensures that all the subclasses use the functions in the superclass similarly. The right screenshot shows how a subclass extends itself from a superclass, making it able to inherit its functions. We simply add the keyword extends followed by the superclass name. Allows the subclass to access functions in the superclass. We still have to use the keyword super in the subclass to be able to call the overridden methods in the superclass.
That's all for now.
See you later.